Hi everyone, welcome to my channel Code with Ease. Hi Varsha. Today we will talk about this lead code medium question which is called insert, delete, get random in constant time. So here we have to design a data structure where three operations are being supported. One is the insert, second is the delete, and third is the get random. So now these are the companies in which this question has been asked. So we will talk about what is the significance of this question, right? So insert delete is something which is very common. Like any data structure that we usually use the insert and delete. We also use update, checking if the data structure is empty. All of that is very commonly used. Now, why is the get random implementation important? Now, suppose if there is a load balancer, or maybe there are multiple load balancer in case of a web application, and you want to evenly distribute your workload so that not any one of the load balancer is overburdened with the request. So maybe a randomized implementation over here where it will randomly pick which load balancer to give the request to. If that kind of implementation we are able to write, then we will have a uniform allocation or uniform distribution of the workload, and there is no bias as such. So that is why knowing about the random implementation is important, and that is the reason why this question can form a solid base where you can understand how the get random works so that we can use it in multiple distributed systems architecture also. So let's begin with the problem statement. We have to design a randomized class or a randomized set where the first operation is insert, where we will insert an item to the set if it is not present. We will return true if the item is not present and false otherwise. So if, of course, if the item is not present, only then we will insert. So we'll return true and false otherwise. We will remove the item from the set. So we will return true if the item was present. Obviously, if an item is present, only then we will remove it. Otherwise, we will not be able to remove it. Now the third is the get random, right? So we have to return a random element from the current set of elements. Like if there are three elements, any one of the three elements can be returned. The only thing is each item should have the same probability of being returned. So if there are three elements and whenever I'm trying to access, let's say the element at index number 2, that element, when I'm trying to access multiple times, the same element should get returned. It should not be like sometimes element 1 is coming or sometimes element 3 is coming. It's not like that. It should be like every time any element I'm trying to call, it needs to have the same probability of being returned. So if you take a look at the example, okay, one more important thing is all of these operations has to happen in constant time. Now insert and remove, if we think of a hash set, we know that insert remove actually happens in a constant time. So there is no problem. We'll use a hash set to implement this. So that's not a problem. The problem is the get random method. Now when you try to do get random and hash set is actually unordered. Any data structure which has hashing mechanism, underlying a hashing mechanism will be unordered. So the same probability of being returned is not true. Sometimes maybe one element you get, and then sometimes when you again call, maybe that element is not returned. Okay, because they are not in contiguous memory location. So something like a list, array, fixed size array can actually give us this probability. So something like a list or array can actually help us in achieving this goal where the element will always have the same probability of being returned. So just by implementing the hash set is not enough. So the main trick over here is you have to implement the insert, remove, get random. All three have to happen in constant time. So if you take a look at this particular example, what is happening first? Insert 1. So we inserted 1 to the set. So now we try to remove 2 from the set. So if we are trying to remove 2 from the set, we are not able to remove it because of course 2 was never inserted. So it will return false. Then we actually insert 2. So 2 is added successfully. Now the set is containing 1 and 2. Now we do a get random. So when we do a get random, probability of being returned same means either 1 or 2 has to be returned. Now we remove 1 from the set. So now the set will only contain 2. 1 is removed. Now again we try to insert 2, but 2 is already in the set. So it will return false. Now again we do a get random. So remember we removed 1. The set is only containing 2. So when we call get random again and again, every time 2 should be the only element which gets returned. In the previous case, when the set was containing 1 or 2, it doesn't matter which index I'm calling. If I'm calling the index at 0, then I should get 1. If I'm calling the index at 1, I should get 2, no matter how many times I call. So this is the overall importance of this get random. That you will randomly get the values, but the value that is get should be consistent. So this is about the example, and these are some of the constants which is given. So whenever get random is called, it is not possible that there is no element in the data structure. It will only be called when there is at least one element in the data structure. Okay. So now let's go to the whiteboard to understand how can we write the solution for this. We have three operations: the insert, the remove, and the get random. And we said that we are going to implement the set. So let's start with the hash set, which we will use. So we know that in case of a hash set, whenever we try to insert an element and if it doesn't exist, it will obviously try to insert it and it will return true. Otherwise, it will return false. So we are good. We have a hash set and we try to insert 1. 1 was not existing, so we inserted 1. In case of remove, if we try to remove something which doesn't exist, let's say I'm trying to remove 2, this will return false because 2 is not existing in my set. So this will return false. If 2 was existing, it would have returned true. Again, if I try to insert, so I'll try to insert 2. 2 was not there, so it inserted successfully. Now when I'm trying to remove, let's say I'm trying to remove 1, right? Like we saw in the previous example. Now since 1 is existing, 1 will get removed. Now coming to the GetRandom implementation. Now coming to the GetRandom. So over here, where we told that if we have this much, these two numbers only in the set, either one can be returned or either 2 can be returned. And every time we call the GetRandom, if I'm going to index 0, I should always get 1. If I'm going to index 1, I should always get 2. That is the intention. Now we know that sets are unordered. So every time I go to index 0 or every time I go to index 1, there is no concept of index also in the set. So the problem is, in case of GetRandom, implementation is not possible if I only take a set, because sets are unordered. What is an ordered collection? A list or array. So let's say I take an array. So I will take an array. So what is my data structure now looking like? I have a hash set and I've also added one array. Array why? Because I want the order to be maintained. So the moment I add something to my set, I will also add it to my array. So I added 1 already, I will add 1 to my array. I added 2 already, I'll also simultaneously add to my array. Now whenever it comes about the GetRandom, if I call the GetRandom on this particular array, I have 2 elements only. So either 1 will get returned or either 2 will get returned. No matter how many times I do a GetRandom, it will be only called on this much range or these many elements of the array, which is only 2 elements. So GetRandom on 2 elements, either of them will be returned. So I am sorted. So far so good that we have used a hash set and an array and we are able to do all the operations in constant time. Why? Because insert in a set, constant time. While I'm inserting in the set, I'm also inserting into my array, constant time. When I'm trying to remove, I will remove from the set. Here also I'm going to remove from the array, not a problem. But the problem is, if I have one more element, that is 3, and I have now 3 elements into my array. So when I do the remove, when I call the remove, I will either call the remove on 1 or I will call on 2 or I will call on 3. Now let's say I call remove 1, which means this element. So 1 will get removed from the hash set and 1 should also get deleted from my array. Now when I'm trying to delete 1 from the array, now try to understand this carefully. When I remove something from the set, this element is got deleted from the set. Now this element also gets deleted from the array. So this element is now gone. So this over here at this position, I'll have a 0. I'll have a 2. I'll have a 3. So I have 3 elements. One of them is 0. One of them is 2 and one of them is 3. Now think, if the GetRandom method is being called on this, will I get the right result? I will not get the right result. So what I should ideally do is I have to do the shifting. Why I have to do the shifting? I have to do the shifting so that my array size becomes equal to 2 only. So let me just add 3 over here just to be consistent between the set and the array. The array size needs to come back to 2. If 1 is removed, the array size needs to come back to 2. If it doesn't come back to 2, it will incorrectly tell me there are 3 elements, whereas there are only 2 elements because 1 is already removed. So then what should happen? If I do the shifting of elements, which means I have to shift all the elements. In worst case, now shifting will cause me a time complexity of order of n. So this I am violating my required time complexity of constant. And that is the reason why just by using an array and a hash set, my remove method will cause a problem if the item is being removed from the middle of the array. If it is removed from the end of the array, I do not care. If it is removed from the beginning of the array, then it is a problem. If it is removed from the middle of the array, then also it is a problem because of the shifting of the elements. If it is removed, like let's say if 3 was removed, I didn't care. 3 would have gone and my size would have shifted only to 1 and 2. So only because the shifting is coming into picture in case of remove, and that is causing the wrong GetRandom implementation. So what do we conclude? If we use a hash set and array, my insert is working fine, but my remove, if it happens, remove is happening on the beginning of the array or remove is happening on the middle of the array, then my GetRandom method's return value will be altered. I mean, it will be incorrect as we saw. So the remove and GetRandom will get messed up if I use a fixed size array in this case. So because of the remove method going wrong, the GetRandom will also produce the incorrect value. So this implementation will not work that I have set an array. Now how do we design it further? What can we do? So that we don't have to do this shifting, right? If I have to get a constant time, okay, so if I have to get a constant time in case of insert, remove, and get random. See, insert was not a problem for us. Our problem was the remove. If I try to remove something from the middle or from the beginning, if it was possible, if possible, to know in advance, to know in advance where is the element in the ordered data structure. Like when I say that I have an array, I want to remove something from here or something from here, from the middle. Now, if I knew in advance that this is the index, then I could have just gone to this that index and I would have removed. Instead of me trying to shift the elements, I could have gone to that index, removed that element, and replaced that with some other element. The only thing is, only if I knew from advance where is the element which needs to be removed, where is it sitting in the array, like where is that index in which that element is sitting, so that I can remove it in constant time. I don't have to shift the elements, I can maybe replace that particular position with some other element. If this was possible, then it would be great because we could have done it in constant time. To know which element is sitting in which index, we need some kind of a lookup table. And we know that in that case, HashSet alone will not help us. So in that case, we would need a hash map, because a hash map stores the key and the value. It will store that, okay, this is the element and this is the index in which this element is located. We have to convert our hash set into a hash map. So let's do that. Now our hash map comes into the picture. Now I have added element number 1. So I have an array like this. I have added 1 to index 0. So I will say 0 is it. It's located at 0. Now I added 2. 2 is at index 1. 2 comes over here. It is sitting at. So this is the index and this is the element. Correct. Now I added 3. Index is 2. 3 is sitting there. So my insert looks great because whenever I'm trying to add element to my hash map, I'm also adding into my array and it's happening in O of 1. So my insert is doing a great job. Now when I try to do a remove, okay, now what happens? Now if we talk about the remove, how will the remove happen in this case so that we get the constant time complexity? So let's say I want to remove the middle element only because that was the main constraint for us. So let's say I want to remove 2. So I will say the method will be you have to remove 2. If I have to remove 2, what are the steps that I have to do? What I'll do in this case, I want to make sure whenever I'm removing element from the middle, from the beginning, the size of the array should shrink. Like initially what it was happening, 0 was over there because it is removed, it will come into the default value. I want to shrink the size. And we know that when we access element at the last index, that happens in constant time. So this is the main thing which we will make use of. Access at the last index. So what we will do, we will access the last element, and now we anyway don't care about what we will do with 2. So what we will do, we'll access the last element and put it in the not 2, I will say that put it in the index to remove. So wherever which index I want to remove, this index, what is this index? 1. So I will put 3 over here. I'll just copy 3 over here because I can access 3 in constant time. So I will access 3 over here. So I'll put over here. So 2 will be, now here it will be 3 over here. So now this becomes 0. Okay. Now once I do this, I also have to manipulate my hash map because 3 is initially was at index 2, but now 3 is at index number 1. So I have to update the hash map. So my second step will be update the new index of what? Of the last element. So basically last element is sacrificing its position and coming to wherever index that element was there, the ones which we are trying to remove, it's coming to that particular index and sacrificing where it was sitting, that is at the last index. We have updated the new index of 3 and 3 is now sitting over here. Eventually what do we need to do? Eventually we have to update, we have to remove it from the hash map, we have to remove it from our hash map. So this particular element is removed. Now how did we get 1? So we also have to access this index of 2 and put it update over here. So that is something like the code, but what I'm trying to say is your last element will come over here, the last element's index will get updated. Once the last element is sorted and settled in the new position, then we will remove our element which we anyway wanted to remove. So now when we do that, what happens is now my size of the array is only this much. I'm only going to consider this much of the size of the array. So just want to reiterate that whenever the element that you are trying to remove, access the last element, okay? Update your index that you want to remove. In that, you update that particular element with the last element's value, okay? When you do that, after doing that, you also update it in the hash map. What you will update? You will update the hash map's entry for the last element to the index of where your old element was. So 2 was at 1, so 3 will get updated to 1. You do that. Finally, you remove from the hash map. You also remove this particular element from the array. Because initially what we will do is we will use something called the set operation. Okay, when we do set operation, this takes in two parameters. One is the new index and the element. So when we do the set operation at index number 1, we will say that set at 1 the last element, which is the value of which is 3. So when I do 3 over here, just try to understand this, important it is. When I do like this, I have 1 over here, my 3 was over here, 2 was over here. I cancelled it, I have put 3 over here. So far I had 3 elements. Only when I do the hash maps adjustment and all of that, then I also have to remove this 3 from here. So I will call the remove method of the array list. We're going to use the array list in this case. So we will remove 3 from here. So then my size, my new size, what it will be? Then my new size will come to 1 and 3 only. So what are the different operations that we will do? Different operations is, like I said, get the last element, set it to index to remove position, update hash map with new position. New position of what? The last index. Sorry, the last element. See, it might sound a little confusing, but try to think it logically. You get the last element, you set it to that particular index where you want to, wherever the index to remove is happening, you are setting it at that position. You're updating the hash map with the new position. Then you remove two things. You remove the old element from hash map and you remove the last element from the array, which means I removed 2 from here, I removed 2 from here, and I removed 3 from here. Only then, why is this important? You cannot have 2 anymore because your size needs to be shrunk. Your hash map should only contain 2 elements. And you have to remove 3 from here because otherwise if there is 3 over here also, 3 over here also, your GetRandom method will again mess up. You have to eventually remove the item from the last. The last element, wherever it was, that position has to be removed because there is no, logically doesn't make sense for that to stay, right? Because 3 is now at index number 2. Sorry, index number 1. So 3 was initially at index number 2. Now it is index number 1. So there's no, it doesn't make sense for 3 to stay in the array at that particular, at the older position also. So these are the steps that we have to do. So what is the outcome of this? Insert happened in constant time. Remove is also happening in constant time. Why? What are the things we are doing? We are getting the last element, setting to index of this. So that is constant time. Fetching the last element, doing a set operation is constant time. You're using ArrayList. Updating hash map, update operation in a hash map, again constant time. What are we removing? The old element from the hash map. It's just a remove method, constant time. What are we removing? The last element from the array, like we did a get of this. We are again doing a remove on that. That is also constant time. So all the operations, as a result of that, your entire remove operation is happening in constant time. So where insert is also happening in constant time, remove is also happening in constant time. Now what about the get random method? We have also done the changes for the get random method simultaneously when we did the changes for the remove. How? What does a get random method do? It will give, you give a certain range and it will generate the random values. The range problem is already solved when I remove the last element from the array. So my range was initially 1, 2, 3. Since 3 moved over here and I removed 3 from here, my range, the new range is this much. So I have only 2 elements. Because I have only 2 elements, on this I will call my random method. And because I'll call the random method on only 2 elements, instead of the previous 3 elements, I will always get the correct result. Now the probability of getting 1 or getting 3 is correctly defined because I have only 2 elements. So this is how, by using a hash map and an array list, we have been able to solve all the 3 operations in constant time. Let me show the Java code now. See, this is the code which I've just put inside image so that it's easier. What are the things that we are doing? We are taking a hash map, we are taking an array list, and we are just defining the random. Insert operation, if the value is already contained, why will I insert? Return false. If it doesn't contain, I will add it into my hash map. Here it is the hash map addition, and I'm adding it to my array list. So values.add, I will add the value, and inside the hash map, I'm adding the element and I'm adding the index position. So initially when your array is empty, that will be 0. So that is a values.size. Then it will increasingly grow, and that is how we will change the index position. Now this is about the insert. Now let's talk about the remove method, the actual trick part. So over here, what are we doing? If it doesn't contain, what are we going to remove? We will return false. Then we are accessing the last index, the last element, and the index to remove. The last index, how are we getting? N minus 1. The last element, we are getting it from the hash map. Last element's index position. The element itself. You got the last index, but you don't know what's there at that last index. So you're getting the last element from the hash map. How are you getting the index to remove? Which index it is? Because you are getting the value. You have to know where is that value sitting. From the hash map, you're doing a get operations. So whoever's value you want to remove, where it is sitting. That is why you get this. Once you get these 3 values, then it is simple. Like I said, the set operation. Here your last element is being set at the index to remove. Then your hash map changes. Here your hash map changes. The update in the hash map where you're updating the value of the last element with what? The new index. The 3 was going to sit at index number 1 now. And finally, these are the removals. What are we removing? From the array, we are removing the last index. From the map, we are removing the required value, which is the 2 in the example that we saw. So these are the steps that main thing is this. You're getting the last index, the last element, and the index to remove all the necessary information that you want to get. And the very simple implementation is the GetRandom. So random.nextInt, we are doing it on what? The values.size. That is why I talked about shrinking the size. Shrinking the size of the array. If I have to shrink the size, if I cannot shrink the size by doing this, values.remove, this is what is helping me in doing this. If I don't remove the last element, I will not be able to shrink the size. And now, when I generate the random value, I'm doing a values.get because I'm getting it from the array. Now, when I get the random value, I will get the correct index because I'm generating the random value in the correct range. The range is important. So that's it. This code is going to be available in the GitHub. That's about it. So this was a very lengthy video because the entire designing of the data structure we discussed, time complexity and everything we discussed, the code we have seen. So thank you so much for watching today's video. Do subscribe to the channel if you haven't already, and don't forget to like and share this content. Thank you so much.